Welcome to this session. In this session, we discuss the solution of a problem, integral of dx over square root of a squared plus x squared. So solution. So since the integrand is of the form alpha squared plus x squared square root, then we make the substitution. The trigonometric substitution, x equals to alpha tan of theta. Now, in our case, so it means that we relate to square root of alpha squared plus x squared is square root of a squared plus x squared. Now, this should be obvious to see that alpha is a. So our substitution is x equals to a tan of theta. And from this, you say tan theta alone will be given by divide through by a x over a. So which means you can draw a right angle triangle, or even before drawing the right angle triangle, let's now interpret our integral in terms of theta now. So by saying x is a tan theta, then is the same language as saying dx is the same as a sec squared theta d theta. Now the integral, this implies the integral of dx over square root of a squared plus x squared will be the integral, where there's dx you put a sec squared theta d theta. And let's quickly see how this will simplify to. So square root of a squared plus x squared is the square root of a squared. X itself is a tan theta, so squaring it, you get a squared tan squared theta, which is the same as the square root, factor out a squared, 1 plus tan squared theta. Now, 1 plus tan squared is sec squared. So this is the same as the square root, a squared sec squared theta. And the square root of a squared sec squared theta is nothing but a sec theta. So therefore, this square root is just a sec theta, which will reduce our integral to a and a cancels, 1 square cancels this one here, so this be just sec theta d theta. And you see integral of sec theta d theta is a standard integral whose value we know. So we say, therefore, integral of dx over square root of a squared plus x squared is the integral of sec theta d theta, which is ln of sec theta plus tan of theta. Then you add a constant of integration. But you don't stop here because theta was not in the question. It's our own making. So since tan theta is given by x over a, then we draw a right angle triangle. So put here theta, opposite is x, adjacent is a. So this must be the square root of a squared plus x squared. So the only problem we have to define is sec theta, because tan theta already is x over a. So sec theta, sec is the reciprocal of cosine. So because cosine is adjacent of hypotenuse, so sec will be hypotenuse over adjacent. Thus, the integral of dx over the square root of a squared plus x squared will be given by ln of sec theta is square root of a squared plus x squared divided by a plus tan squared is tan theta is x over a, and then plus c. So therefore, this is the solution to our problem. Thank you.